Good morning. Happy Tuesday. I hope your Monday, first day back, went well. And I hope you were able to give yourself a little grace as you started back after being off for a couple of weeks, as you went through your classes and your lessons yesterday. So we're going to head back into chapter 5 today for math. And one of the first things that we're going to do is a quick warm up. I mentioned in yesterday's video that with the vocabulary, we need to just practice it a little bit so you understand what each of the terms, the coefficients, the constants, the variables, what that all meant and how you apply it. So we're going to spend some time this morning, just right off the bat in the warm-up, doing that. Afterwards, we're going to head into the book, and so you will definitely need your Volume 2 textbook, like I mentioned yesterday. And we're going to actually start lesson 1. We're going to do some evaluating expressions and how that looks and how we work through it using order of operations and our integer rules. You'll end the day today doing a couple of just review quiz lessons that's on our Math 7 Google Classroom page, just to review what we did throughout the lesson today. So as a reminder, don't forget that ALEKS, right, is this week as well. You should be working, actually that'll be tomorrow where you spend some time on ALEKS. And don't forget that you're still looking for 5 lessons, right? 5 lessons completed, 5 lessons learned. And so if you are working on that and a knowledge check is coming up, that's fine, but make sure on that knowledge check you're getting it done. It should take about 30 minutes, so make sure the knowledge check is getting completed 30 minutes. And again, it might take a little bit more, but at the same time, if that's popping up for you for the week, put the 30 minutes in so that we see that. And then as well, or the 5 lessons you should be learning, okay? So I need you right now to take out your line paper from yesterday. So where you did your vocabulary, if you can keep going on that paper, or if you need to grab a new sheet, we're going to do a couple warm-up questions together. And so I'll meet you back in just a second. Pause the video and get your supplies. Okay, so here we go. Let's take a look at your warm-up today. So you can put it on your paper, warm-up January 5th, 2021. And let's start looking at number 1. So you don't have to copy the questions I have there. We'll work through these together, and you can just kind of work through them with me and write down the answers and what you feel you need to on your line paper. So number 1 says, which examples are algebraic expressions? And so we talked about, what an algebraic expression is based on our vocabulary from yesterday. So let me actually go back. And you'll see, and you should have this in your notebook, that an algebraic expression is an expression that contains variables, numbers, and at least one operation. So keeping that in mind, if I look at A, B, C, and D here, I want to know which ones are examples. What is considered an algebraic expression? Well, x minus 7, letter A. There's my variable. There's at least one operation here. It's a subtraction sign. And there's a value there. It's 7. Absolutely. Letter A is an example of an algebraic expression. Letter B, 3x plus 4. Okay, so again, there's my variable. It's x. I have numbers absolutely in here, so 3 and a 4. And then I have an operation. It's adding. It's addition. So this, letter B, is also an example of an algebraic expression. Letter C, 1 plus 8. So do you see any variables in that? I don't. And so right away, if you don't see a variable, this is not considered an algebraic expression. This is actually what's called just a numerical expression. 1 plus 8, is 9, but it's numerical. There's no algebra. There's no variable in there. Look at letter D. 5x minus 2 equals 12. All right, well, I see my variable. It's x. I see values. I see a 5. I see a number and a 2. And I see an operation. I see a subtraction sign. But there's one thing that shouldn't be here for it to be considered an expression, and that's an equal sign. This is actually an equation. So when you have something like this with that equal sign, you would solve it and you'd find what x is. You'd find that value. This is an equation, not an expression. So in this case, I'm going to cross it out. Okay, so letter A and letter B are examples of expressions. There is a difference between an expression and an equation. Okay, number 2, identify the terms, coefficients, constants, and like terms in the following expression. So once again, we talked about these vocab words yesterday. We talked about what terms were, talked about coefficients, constants, and like terms. So you're going to see the expression here, 2 plus 3b plus 8b. And so let's take this and break down what we have. Terms. Now remember, this is parts of the expression. So when I look in that expression, the parts of it, I see a 2. So that is considered a term. So I'm going to list it. I see a 3b. That is also considered a term. I'm going to list it. And I see 8b. That is also a term. Now remember, terms are separated by an operation, an adding sign, a subtraction sign. So these are all separated. All terms are separated by adding signs. I have 1, 2, 3 terms in that expression. 3 terms. Coefficients. So coefficients is the numerical value in front of a variable. And so I look at my expression and I find where the variables are. Well, I have variables of b. And in front of the b, I have a positive 3 there. So one of my coefficients is a positive 3. I also, though, have in my other term an 8 in front of that b. That 8 is considered a coefficient. And so I have 2 coefficients in my expression. 3 times b, the 3 is the coefficient. 8 times b, the 8 is coefficient there. Now, why am I not listing the 2 that's out front? Well, that's a constant. Constants are the ones that stand alone. It's a fixed value. It doesn't have any variable next to it. So the constant is a 2 in that example. And then my like terms. So when we talked about like terms, those are terms that have the same likeness. They look like each other. They have the same variable. Or they could not have a variable at all. So for example, in that expression, if I'm looking at like terms, I look to see what's similar. And these 2 right here have b's next to them. So my like terms here are 3b and 8b. That's a like term. Both have the variable b. I'm not going to list the 2. That's a constant. But there's nothing else like that. There's no other constant in that expression. Okay, let's try another. Okay, let's go to the next page. So we're going to do the same thing, except for I put a different expression here for us to look at. So we've got 9y plus negative 4 plus negative 11y plus 7. And so I first want to be able to identify the terms that are here. So the first term is 9y. I'm going to list that. And then the next term, remember, everything is separated with an add or a subtract sign so you can see the terms. And so the next one here is negative 4. That's a term. The next one right here, because here's an adding sign. The next term here is negative 11y. And the last term here is a 7. Every single one of those terms have an adding sign in between. I have 1, 2, 3, 4 terms in that expression. Coefficients, the numerical value in front of variables. There's a 9 in front of that y. All I have to do is write down the 9. I don't need to put 9y, just the 9. The coefficient, the number in front of the variable, just the 9. Okay, I see another one. As I look through the expression, there's the other y, and in front of that other y is a negative 11. That's a coefficient. So I have 2 of them in my expression, a positive 9 and a negative 11. The constants, right? So these are the fixed values without a variable next to them. So negative 4 is a constant, and positive 7 is a constant. Negative 4, positive 7, no variables, letters next to them. Like terms, the ones that are considered the same, have the same likeness. So I know that I have a couple of y's here. So my like terms, the way I'm going to group them, I'm going to group the 9y and the negative 11y. Those, again, are considered like, so those are grouped. Now I have another group of like terms. My constants this time, I actually have two of them in the expression. So I have a negative 4 and a positive 7. Those are considered like because they don't have the variable next to them. They're a fixed value. They're constants. So I'm just going to leave a little space here. And I'm also going to write down negative 4 and positive 7. I have two groups of like terms. Okay, let's try one more. Number 3. Identify the terms, coefficients, constants, like terms, just like we've been doing. But this time I gave you 8t minus 6 minus 6t plus 23. So the other two expressions that we just did in letters A and B, they had addition signs all the way through. And so now this one's a little different, right? We're using some subtraction signs here. This is going to be pretty important in order to correctly identify what's needed in this example. So you remember with your integer rules that anytime we see subtraction, we do use leave change opposite. So I'm going to write that next to here, LCO. And we're going to actually need to use that this time. So what we're going to do is take and leave the 8t all by itself. And instead of the subtraction sign, leave the 8t, change to addition, opposite, that's a negative 6. Leave the negative 6, change subtraction to addition, opposite, that's a negative 6t. Anytime there is a subtraction sign in front of a value, it's negative. So I did that for both. The reason why is because now when we go to talk about our terms and our coefficients, we want to make sure that we identify it correctly as a positive or a negative value. So let's talk about the terms here. So we've got 8t, that's a term. We have now negative 6, that's a term. We don't want to put positive 6. There's that subtraction sign in front, so it is a negative value. We have a negative 6t as a term, and again, that is also a negative value. We want to make sure we identify that term correctly. And we have a positive 23. So altogether, 1, 2, 3, 4 terms. Okay, coefficients. The numbers in front of the variables. So we've got t as our variable here. There's a positive 8 in front of that t. That's a coefficient. And then now when we look over at the other t, this is a negative 6. If you were to put a positive 6 down as the coefficient there, you'd be incorrect. Again, it has a subtraction sign in front of it. And we start working with algebraic expressions, we do have to realize those positive and negative values. And so it is a negative 6 in front of that t. Constants, right? So your fixed values, no variables. So that means this negative. See, I almost caught myself. So this plus negative 6 is a constant. And then at the very end, this is actually a positive 23. It says plus 23. So we have negative 6 and a positive 23 as your constants. Like terms, so terms that are the same. So we're going to look here at the t values again, and we're going to group these. So you have a positive 8t, and what's considered like is the negative 6t. That's a group of like terms, 8t and negative 6t, both have a t. The other grouping is your constants. So the negative 6 and the positive 23. Two groups of like terms. Okay, so we'll practice this again probably later throughout the chapter. We are going to see this as we do some evaluating next in the book, and so we'll reinforce it as we do it. And actually, you're going to practice this when you work through quizzes today in Google Classroom. So the next thing I'm going to have you do is get your book And so we are going to be looking at Lesson 1, Algebraic Expressions, and that puts you on page 349. So I'm going to end this video. You're going to get your book ready to go, and I will set up the next video for us to do Lesson 1 together. I'll meet you back here.